I am Eize de Vries, wind technology correspondent for RenewableEnergyWorld.com. We are here today to speak with some of the teams in a wind power competition between 10 US colleges, and we will report on some of the highlights they have discovered in their designs and some of the challenges also they have encountered. And we move on now to the first group. We are here at the small booth of the University of Kansas, and I will ask a number of questions on the rotor blade design and in fact the whole rotor design, what they have made with a 3D printing process. Can I ask you first how you moved on from the initial design, what you have made, through a second stage and a third stage to a final stage of the rotor blade development, and what challenges you encountered, and so what you have achieved in the end?
So where we started was a more multi-part assembly to where you can see a hub, blade, different component type of integration. What we decided was this was too high of a part count, and actually it took way too long to put together. We actually ran into the aspect of we could even put it on backwards, so we know the customer would too. So what we decided was to move along and go down the line to a hubless blade. As you can see, we run into more of the structural integrity issues with being able to hand loading conditions at these type turns. So we moved on to a different integrated hub design to where each one of the blades can pop apart. Our parts count is still quite low, but the structural integrity of it is a little bit better. Down here what we have is a alumide powder laser sintering blade with ABS plastic 3D printed hub. Here we have the same alumide printed, but as you can see, the flexure, we didn't care for that in our wind tunnel testing.
Okay. Yeah.
So, yes sir.
So, and this is then the final blade you have made, and that I understand that is similar to this blade, but except without painting.
Yes. Mm-hmm. And
so this is actually our finalized design. It's exactly the same as this guy up here. What we ended up doing finally was we printed out the blade with a nylon reinforced glass fiber plastic, basically. We kept the same design here as before, and we ended up making it really nice and smooth. It's been sanded down and processed so we could get a nice smooth flow across the blade. If we look at this one here, this is the exact same thing. If you actually look in here, you can actually see the detail of one single blade and the design, how these fit together. If I take this one here, you can actually kind of see the puzzle piece effect. So if you put them on like this, there's a really smooth connection, but if you put it on backwards, there's a step down here, which is obviously wrong. Do you have anything else?
So I would like to thank you very much for this very good explanation, and also the work you've done and that you have done, and how you moved from an initial design to a final design. And I must say it looks beautiful, also the color combination, and I'd like to wish you a lot of success on behalf of RenewableEnergyWorld.com, and hope you will find a career in the wind industry as well that really find you just as inspiring as this project. Thank you.
Thank you.
Thank you. We are now here at the booth of the California Maritime Academy, and I will be asking some questions about this wind turbine. That is a vertical axis wind turbine with a DOE principle, and the students are explaining us on the choices they made and why they have made the choices and what specific benefits can be expected from this design. So please could you explain us why you have chosen for a vertical axis design?
Sure. So the main reason why we chose vertical axis wind turbine is for such a small design and application for mobility reasons. It works in turbulent conditions much better. So in urban environments such as buildings and cities and things like that, the wind can go in any direction and can be blowing at any speed. And vertical axis is just much better for that because you don't have to have a yawing mechanism on it, and so it makes the design much simpler.
So that means it can draw wind from any direction without needing a magazine. Yeah. So can you say something about the specific rotor design? For instance, why you chose for having this material here, but also an aerodynamic shape here. What is the benefit of that?
Sure. So the main idea with our wind turbine design was how light it is. So with such a small turbine, it produces very little torque, and so the weight is a big factor. So we chose a carbon or a foam core wrapped in carbon fiber, and then it's a NACA 15 airfoil. And then we also replicated the NACA 15 airfoil here for simplicity while we were making it. And we chose the aerodynamic profile for the strut. Although it's not producing lift, it's greatly reduced the drag that the turbine is experiencing because it's, again, such a small torque that we need to eliminate any parasitic effects that we can possibly have.
So, what about the aerodynamic efficiency of a vertical axis rotor? I understand that the efficiency is a bit lower, but you managed to find a clever solution on it and within the rules of the Department of Energy. So what exactly have you done?
We chose to go vertical axis because even though it's less efficient, we have a greater swept area within the design parameters that the DOE has given us. So with that, we are hoping that we can compensate for the smaller efficiency by being able to harness more energy out of the wind.
Could you perhaps graphically show what exactly the swept area is of this machine?
Okay, so the blade is 45 centimeters high, and then our strut is half of that, so 22.5 centimeters. And so that means that as this blade moves around the entire area that it's able to operate in, it's sweeping the entire 45 by 45 centimeter cube that we can potentially harness power out of based on the requirements that were put upon us for the competition.
Thank you very much. That was a very interesting explanation, and we like to wish you a lot of success with your design on behalf of RenewableEnergyWorld.com. Thank you. We are now at the booth of the Boise State University. We will be talking about a micro turbine what has been developed for an educational purpose. Could you explain a bit more on the background, so why you developed this turbine specifically for this background or for this application?
So we were tasked with creating a small wind turbine that could produce more than 10 watts for this competition. And knowing the amount of power we were likely to get out of it, that kind of limited our business plan a little bit and possible markets for a turbine of this size. So as we were thinking of different business plans that could operate in around 10 watts, we came across the idea of using it as a tool to educate high schools and universities and other technical applications. And one of the reasons we came across this idea was that we were learning so much from developing this turbine, designing this turbine, and seeing how changing different aspects of the turbine affected the production and the power. We learned so much that we felt that it would be a really good opportunity to teach others about wind energy.
Thank you very much. So what is the main ignorance point in wind power in your concern in the US population? Do they not understand it at all, or are there some aspects they are ignorant about and they need further education?
I think a lot of it has to do with exposure. Especially in Idaho, there's a lot of people that are more dependent on gas and non-renewable sources of energy, and they just don't know enough about wind energy. So if we can get these turbines into schools and get them exposed and to these, how useful these applications can be, we think that that's a great way to improve awareness in wind energy.
Thank you. And did you already get some positive experiences, or is it still too early and you have to wait for your wind tunnel test results?
We've gotten a lot of positive feedback so far. We had our design review today, which went really well, and the judges seemed to think that we were in the right direction as far as our business plan was concerned. And then also we've been testing too, and so today we'll finish the tests. But so far it looks like everything that backs up our business model has performed really well.
Can I thank you a lot for this good explanation, and I wish you on behalf of RenewableEnergyWorld.com a real big success with your product, and so let's hope that it will contribute to educating the US population in the benefits of wind power. Thank you very much.